All right, good afternoon, everyone. Hopefully you all in the back can hear me okay. All right. Welcome to Comp 1200C. Comp 1200C. I wanted to spend today just letting you know what to expect this semester. Let me start here with all access. This is dated. If it does have any dates on it, the dates are incorrect. So I'm sorry I didn't update that, but all of you have already been enrolled in Zybooks and Vocarium. You should have received an access code in your email from, I think it's no reply at maybe the bookstore, no reply at something. You can opt out of all access. All that does is they've already charged, or they will charge your student account for Zybooks and Vocarium. You can opt out if you want to, but you won't pass this class. You do need both of those things in this class. The majority of your grade will come from Zybooks and Vocarium assignments. So I encourage you not to do that. You can choose to opt out and try to purchase it on your own. It's going to be the same price. They've worked with the people at the bookstore so that the bookstore is able to charge the same thing you would pay if you were to buy it on your own. So I encourage you, please don't opt out of all access. You'll need both of those things. And we'll discuss both Vocarium and Zybooks later. The other benefit to doing that is those of you that do have scholarships, they're able to charge that to your scholarship account versus sometimes if you need to get electronic textbooks, you're not able to charge those textbooks to your scholarship account. So because it's being billed automatically, it's part of your AU bill, it'll also automatically be applied to that scholarship account. So where do we begin? Let's start with differences between this semester and last semester. I know we don't even know about the class yet, but I want to talk about one big difference between what I'm going to do this semester versus what I've done in the past. This semester, every single one of your assignments, not the quizzes and not the exams, every single one of your assignments is due on the last day of class. I don't know if that's a good or a bad thing. That's typically not a good thing because it encourages you not to do your assignments. And the assignments really do help you. It helps enforce the content, what we're learning in class. That being said, they do have due dates. If you will, let's take a look at an example of one. So take this one, for example. If we were to click this, you can see it has a due date of January 25th. If you do submit your Vocarium assignments, this is for Vocarium only. If you do submit these by that due date, you will get an extra 5 points added to the assignment. So this is what would typically be the due date. If you submit it by this date, you'll get an extra 5 points. Otherwise, you have till the end of the semester to complete it. I encourage you not to wait too long to do it. Don't wait till the end of the semester to do it. It's a lot of work if you try to do it all at once. I promise you it is. Every assignment that you will ever be asked to do this semester is already posted and it's already available. So you can look at every assignment for the entire semester, no surprises. I like to be upfront. I like to give you everything in the beginning. If you look at the way your home page is laid out, everything is dated and organized by time and how we're going to go over it. So for example, today we're going to, provided we can get through the introduction quickly enough, we're going to try to get through this introductory lecture here. This zyBooks chapter 1, ideally, you'll have it done by the end of the week before next week begins. This quiz is due in a couple of days. So there is no, again, the quizzes aren't due at the end of the semester. Quizzes are due when the module is complete. So you have multiple modules here. You can see this module is for the time period of January 19th through January 25th. This quiz is due on the 25th. So it's due at the end of the module time. The quiz is over zyBooks. zyBooks, you can look at it like your digital class textbook, except you can do exercise in it and it's got animations and other things. The quizzes will come directly from zyBooks. So while you don't have to do this, you don't have to complete this chapter until the end of the semester, you will be quizzed on it anyway. And the quiz is due on the 16th. So I think it'd behoove you to do it anyway on time, or at least take a look at it. Midterm and the final are already posted and the dates are posted. So the midterm is going to be on Wednesday, February 23rd. The final will be on Tuesday, May 3rd. So if you ever wonder when they are, just go to your homepage and scroll down. I have the dates in Canvas already. They will be available all day. I have online students as well. I believe it's asynchronous. I'm not sure, which means they're not required to attend class via Zoom at the same time we do. That being said, I will stream class via Zoom, every lecture, just like I'm doing now. All of our lectures will be recorded, so you can always go back and watch them later if you'd like. But because of the online students and other issues, what we typically do for the quizzes and exams, we don't take them in class. They will be available all day. Your midterm and your final will be available all day on May 3rd and February 23rd. So they'll open up at 12 a.m., they'll close at midnight. So you have all day to take it. They do require something called the Respondus Lockdown Browser. It's just a web browser like Chrome or Firefox with some security features built in. I would encourage you, if you're going to be taking it on your computer, to click this link right here. I'm going to click Take the Quiz. And you'll notice, since I did not open this from that browser, it's going to ask me to download it. Please use this link. You can go to Respondus and download the browser yourself, but the configuration won't be set up for Auburn. This is set up for Auburn. As soon as you open this up, it should take you straight to Canvas, and you have to log in through this browser to be able to take any quizzes or your midterm or your final. So I encourage you to go ahead and do this right away, as you have a quiz due in a couple of days. Let's see. Okay, that's the big stuff. Now, let's take a look at video recordings. So you can always join the class. If you go to the Zoom class, the Zoom tab, you can see all of the video recordings are here. You can just click join if you want to join a session. If you want to view a past session, again, recall I said everything's going to be recorded. You go here to the Cloud Recordings tab, and once this video has been uploaded to the cloud, it'll appear right here. You can also go to Panopto recordings to view past recordings. If you go to the syllabus tab, you can see the syllabus and some more links that take you to class and office hours. If we take a look at the syllabus, my office is upstairs on the 3rd floor. Office hours are right after this class. If you can't make it in person, I will also open up Zoom, so you can also visit office hours via Zoom. If you can't meet me during that time, please email me. And we can try to arrange another time that we can meet either face-to-face or via Zoom. In general, I have an open door policy, so even if, let's say you happen to be in the building and you want to talk with me, you can come by my office, and if I'm there, and if I'm not busy, I will talk to you. If it's you just need help or if you just want to chat, I do have an open door policy. So I will talk to you even if it's not office hours. So class, we're in class now, 4 to 4:50. This is when I'll be streaming Zoom. Of course, it'll be recorded. And then office hours are immediately after this class. Attendance, you should come to class. I don't take attendance. Everything is recorded, so you could never come to class, at least watch the recordings, right? So I think it would, I do cover a lot of important things in class, and some of you will call me mean for this, but I will sometimes get emails and students will ask questions that I covered in class, and my answer will be, please go back and watch the recordings. So please come to class or watch the videos, do one or the other. I do try to cover relevant topics in the class, things related to homework assignments, any announcements that I have to make, I will always do via Canvas. So make sure you keep an eye on the announcements tab in Canvas. Any announcements I need to make to the entire class, that's always where I'll post them. Here's the grading breakdown on what everything is worth in the class. I will do a lot of quizzes and exercises in here. The quizzes will be over zyBooks. Exercises will typically be programming exercises that we do in Vocarium. We'll open up both of those tools in just a moment. There's no makeup if you miss one of those, but I will drop the lowest 2. So that should accommodate people that maybe you miss class or you're unable to take a quiz in the allotted amount of time. Again, you have until the end of the module to take a quiz. Exercises are due the day that they're given. So, and again, it's all in Canvas. So due dates are already there. On an exercise day, you are expected to finish it by midnight that day. If you don't finish it by midnight that day, you will get a 0 and there's no makeup for it. If you finish it before the end of class, before 5 o'clock, you'll get 5 bonus points. Vocarium assignments are always going to be coding assignments. You have to complete these in Vocarium. It's a website. You can get to it from Canvas. They are all auto-graded except for the last one. So for the most part, once you submit it, you should instantly get a grade back. You can resubmit them as many times as you want. There's no limit to the number of submissions you have. You can resubmit as many times as you want. Again, if you submit them by the due date, you'll get 5 bonus points. If you don't, you'll just get whatever grade you get for it. The Vocarium assignments, the grade is based on test cases that you pass. So for every one of the Vocarium assignments, I have tests built into them. If you don't pass any test, you don't get any grade. So I have students ask if I do partial credit. Yes, I do. If you pass some of the tests, you'll get partial credit. But if you don't pass any test, regardless of how close your code is to being correct, you will get a 0 for it. Midterm and final are comprehensive. They come in 2 portions. There's a multiple choice portion that's going to very closely resemble your quizzes. So quizzes are really important. And there's a coding portion that's going to really closely resemble your Vocarium assignments. Right? The multiple choice portion is worth more. It's worth 75% of your grade. The Vocarium portion is worth 25%. Oh, let's go back to the quizzes. One more comment on the quizzes. So once the deadline has passed for the quiz, so for example, the chapter 1 quiz is due on the 16th. On the 17th, the practice quiz will open up. That is not for you to practice to take the quiz. That's to help you practice for the midterm and the final. So I have question banks that I pull questions from for all of the chapter quizzes. Once that practice quiz opens up, it pulls from exactly the same question bank. So theoretically, if you took it enough times, you could pull exactly the same questions you had when you actually took the quiz. But you can use that. A lot of students like to use that as a way to study for the multiple choice portion of the midterm and the final. And you can take those as many times as you want. They don't become available until after the deadline for that chapter's quiz has passed. Don't cheat. If you get help from an online source or from another student, please include that information in your syllabus. Cheating is bad. For the most part, everything you will need to make an A in the class, you won't really need any software. You need a computer and a web browser. That's it. If you want to be able to work along in class, sometimes we'll do exercises together in class. You will want to download and install JGrass. That's what I use in class when I'm doing demos. The instructions are here. If you have a Windows machine, you need to do step 1, 2, and 3 in that order. If you have a Mac, you will, you can skip step 2. You don't need step 2. Instead of step 2, you're going to download something called Xcode. Right, so that's what you use instead of step 2. If you don't know how to calculate a weighted average, I have an example on the last page. Well, let's see. All right, let's get out of here. Vocarium. So quick comment about this tab here. If you haven't logged into Vocarium yet, this won't work. So if I click this now, it's not going to work since I'm an anonymous student, but you'll get some type of error if you haven't logged in yet. If you want to be able to access Vocarium from this tab, the first thing you need to do is go to your assignments. I would recommend you click this button that says show by type. So they're organized on their category. And then we'll just click any of these. Well, the exercises aren't available yet. We'll just click this one. Once you click this button, and it's not gonna, okay, let me get out of student view real quick so I can show you. Once you click this button, it caches your credentials. So Canvas is gonna send your credentials to Vocarium. You don't have a password. You have a username, but you don't have a password. Canvas uses a token. But once you've done that, it's cached in the browser. Then you can click this, and that should show up right here. All of your assignments, everything should show up right here in the Vocarium tab. Let's see. Are there any questions so far? I know I've said a lot. Do you all have any questions for me so far? We're going to take a look at Vocarium and SciBooks in just a minute. Let me open up my chat here. Okay. Then let us start by taking a look at SciBooks. Now, anytime you want, you can click this link and it will take you to SciBooks. Let me leave student view. You can click this link and it'll take you to the table of contents in SciBooks where you can see the entire SciBooks. You cannot submit assignments this way. You can work on them this way, but you can't submit them this way. Right, so when you're working on SciBooks, somewhere at the bottom, there'll be an orange button that says submit assignment. If you don't see that button, it won't push your score to Canvas. So if you just want to review and look over the chapters, this is the way you can do that. If you want to submit an assignment, you need to go to zyBooks from the assignment link. So here's the assignment link for chapter 1. This is chapter 2, etc. So clicking this, now I'm not a student, so I can't show you the button, but it will take you straight to chapter 1. You can work through chapter 1. Now notice when I get to the bottom, here's something that some students trip on. This is not the end of the chapter. This is the end of the section. So you click this button here, it'll take you to the next section. Then you go to the bottom, you click the button, take you to the next section. Then we go to the bottom again. And we keep going until we find that button that says submit. We're almost there. It seems like a lot. I know, I promise you this is much less painful than a regular textbook. We'll go here, here, here. Oh, come on. All right, we're getting there. Okay, now I have a link to the next chapter here. You all will have a button at the bottom somewhere that says submit. It'll show you your progress, how much of it you've completed, what your grade will be. Click the submit button that pushes your grade to Canvas. Now in Vocarium, in zyBooks, there are 2 types of assignments. Let's go to this chapter here. There are participation assignments. So you see the orange color here, and there are coding assignments. The participation assignments just require you to do stuff, just interact with the web page. I'm going to read this, and here, oh, here's a demo. Let's watch this. So I'm going to click start. Let's do it a little bit faster. And basically, for these demos, they'll typically try to interactively demonstrate whatever concept they're covering in this section here. So we'll click this. It's going to do some stuff. We'll go through. Here's what it's doing right now. Here's what's happening. Here's step 4. And notice that once I complete that, I get a check mark here. That participation activity is now complete. So I'll get credit for that when I hit the submit button. So you have these types of activities. Sometimes they're short answers. Declare, and let's just do something wrong. Int XX, that's wrong. We'll click check. It'll tell you it's wrong. If you get frustrated and you just can't figure it out, most of this is pretty straightforward. But let's say you do, you can always just do this. I'd encourage you not to do that. You don't learn a lot this way. But if you just need to get through it, you can't figure it out, you can show the answer. So the participation activities are really just that. Just go through the motions, try to learn. They're to help you learn so you can kind of be interactive with the book. Then you have coding challenge activities. So here is an example of a challenge. Oh, let's look at another one. Here's an example of a challenge activity. These require you to code. So here is where you get to practice the things they've told you about. So write a statement that assigns. Here, let's just click run, and you'll see it's going to fail because I didn't do anything. But they'll tell you what they're testing it with. They'll show you what you printed and what you were supposed to do. This is what was supposed to happen. It was supposed to print this, it didn't. And you can go back and revise this section. So in the beginning, as we're starting out, the challenge activities aren't worth that much. They're worth maybe 10% of your grade, but as you go through the chapters, they become worth more and more of your grade for that chapter. So chapter 1, maybe they're worth about 10% of the grade. Chapter 2 and 3, maybe they're worth about 15%. By the time you get to the middle of the book, the challenge activities are worth close to half of the grade for that assignment. So you really do, I mean, this is a coding class, so you do need to learn how to write code. It is pretty important. But these are the 2 types of activities you'll see on zyBooks. And again, There'll be a button at the bottom. You can submit as many times as you want. Every time you click submit, it'll just push your new grade to Canvas. Any questions over zyBooks? Do we have any questions over zyBooks? Yes. That is correct. They can be attempted as many times as you want. There's only one submit button that just, all it does, it just takes your grade and pushes it to Canvas. Yes. You can, you're not required to do it. So the JGrasp, if you want to install that, that's what I'm going to use in class. So if you have questions and you get stuck, I will answer questions about JGrasp. If you have questions about something else, I'm probably not going to answer questions about that because there are so many different things you could use. I'm going to stick to that. Any other questions? All right, let's move on to Vocarium. Let's go to assignments. And we'll just go to let's look at a homework assignment. We'll take a look at the first one. So click this. This will take you to, your screen won't look like this. Let me show you what your screen will look like. Your screen will look like this. Now, this first assignment is really straightforward. It's not meant to be difficult. It's meant to ensure that you apply your access key before assignments start getting due. So this is a really easy assignment. It shouldn't take more than a couple of minutes. We can go here to instructions. You have the instructions here. You can also find the instructions in Canvas. Typically, your instructions will be in a Word document in Canvas. That's typically how you're going to get your instructions. I'm limited in how I can display it in this little window here. But this one is simple enough. We don't really need that. But I always include a lot of comments. Please be sure to read the comments. They're really important. For example, if you click this one, you can see I write multiple times, don't touch this file. Don't touch this file, you won't get a grade. So don't touch this file. And here, you can upload your work here. This is where you do your work. So typically I'll put lots of comments in here, kind of letting you know where you need to do things. So pay attention, not just to the instructions, but also pay attention to the comments I put in here. I put these comments in to help you complete the assignment correctly. When you're done, we'll just do something here. So we'll just do something here. We can click the build button. And what this will do, this will take this code. This is called code. It's written in a particular language, in C. That's the language we're going to learn. This will take this kind of English looking page here and convert it into machine instructions, instructions that the computer can recognize. We'll talk more about that when we get to the PowerPoint. And once you've done that, once you've made that conversion, then you can click the run button and it'll just do whatever that program says, provided it works. So here I just printed out the word hi. All right, if I did something incorrectly, let's try to build it now. It's going to give me some error message. See, I got an error. I was supposed to do something and I didn't do it. So this is hard to see, huh? It's not really getting bigger. Oh, sorry. You get some error message, go back and fix the error message and then try to rebuild it again. But as long as you're getting errors, you won't have a program to run, right? So when you compile the code, clicking that build button will do something called compiling the code, as converts it into machine instructions. If there are any mistakes in this file, it's not going to convert it to machine instructions. For what? It's just going to crash, right? So it's not going to waste its time doing that until you fix the errors. But once you've done that, you can click run and kind of see what the output is. And when you're ready to submit, when you think it's correct, I'll typically have some type of display statements here that you can use when you build and run it to let you know if you're kind of heading in the right direction. It doesn't include all of my tests, but at least it'll give you an idea of whether or not you're doing things correctly. When you're ready to submit it, you can click the submit button. Let's say yes. And right here, it's running your code. Eventually, it'll be done, and there'll be a grading report, and you'll see a grade show up here. So I'll get a 0 for this. It's not correct. All right, so I get some kind of message. Sometimes the grading report is really long and it won't fit in this window. So we can always go up here to details and say view grading report, and it'll show you in another window here. So look at this message, it did not pass. Your output should be this. Here's what your output was. So I know I have to try again, right? And I can change it and just resubmit it as many times as I want. Notice here to the right, I see a grade, and it should immediately push this grade to Canvas as well. So as soon as you hit submit and it finishes grading, you should also see a grade show up in Canvas. Plus you have that message to help you in case you didn't complete the assignment correctly. Oh, what was I going to say? Oh, I lost my train of thought. If you ever feel like maybe you've messed the file up too much and you want to start over with a clean slate, you can always go up here to actions and reset the assignment. Let's go back to Canvas real quick. Right here, I have a file called Using Vocarium that shows you pretty much everything I just walked you through. All right, what are the buttons? What do they do? Pay attention to comments. How do you do things? I didn't talk about this. But if you do forget, of course, you can always go back to the video, or you also have this document that you can use to help you as well. Any questions on Vocarium? All right, your homework assignments and the majority of your exercises will be done in Vocarium. Anything else? I do have other, this module here, exercises. These are just other things you can use if you want some more practice. So sometimes students say, I don't have anything to practice. I want to practice what we're talking about in class. There's lots of stuff here. I have lots of examples you can use. Some of these we'll actually do in class for our exercises. Some of this we won't. This first one, just resources you can use. If you go to this one here, it's kind of like Zybooks. Just another website you can go to where they explain things maybe differently. They have examples, exercises you can try. Here's another website that is again similar to Zybooks with exercises. And these two links here are just practice exercises you can work on that typically also include the solutions. So if you get stuck, you can look at the solutions. There's tons of exercises you can do to practice the stuff that we're talking about in here. And C, learning a new programming language does require a lot of practice. It's a very hands-on type of activity. It's not a memorization type of activity. So it is going to require a lot of practice to get comfortable with and proficient at learning how to write a program in a programming language. And that is all I can think of off the top of my head. Do you all have any questions for me? No questions? Then let us get started. There's a lot of stuff that we have to pack in this class. So I will sometimes, like today, seem to move pretty quickly through it. Hopefully it doesn't seem too rushed. So let's start with this first lecture here, just some basics. We are briefly going to talk about numbering systems, and we'll spend some time talking about variables, data types, and displaying output. You saw one example of that in that first homework assignment we just looked at together, where I displayed the word hi on the computer screen. Numbering system. So some keywords that we probably already know: least significant digit or most significant digit in a number that's comprised of one or more digits. The least significant digit is the one that represents the smallest unit. So for example, in 201, this represents the 1, this is the 10 spot, this is the 100 spot. This is the digit with the least amount of weight, right? It's the smallest unit. Most significant digit, the opposite. So the 2 in this example, because this represents, even if it were a 1, it would still have a higher value because it represents a hundredths position. Why does that matter? Well, in general, it turns out there are more than one numbering system. So many of us are probably already familiar with that. I typically have a couple math majors in here. For those of us that aren't, decimal is not the only numbering system. Typically, a numbering system is determined by some base. So decimal is base 10, and that base indicates how many digits, how many unique digits you're allowed to use to create a number. So in the decimal numbering system, you have 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 10 unique digits that you can use to create a number. Binary is one that we use a lot in computer science. It's one that's really important to us. Binary is base 2. And there are only 2 digits you're allowed to use, 0 and 1. Those are the only digits you're allowed to use to create a number. And there are more. Again, ternary, there's a hexadecimal, it's base 16. There are 16 unique digits you can use, 0 through 9, and then A through F. They all represent different values, A being 10, all the way up to F, which is 15. But the way if you wanted to convert any other numbering system, binary, hexadecimal, any other numbering system to decimal, it's pretty straightforward to do. And we're going to stick to that for this class. Basically, what you do is you take the least significant digit and you multiply that by some power of that base. So in binary is base 2. You would multiply it by the base raised to beginning at the power of 0. So anything to the power of 0 is just 1. Then you take the next number and you multiply that number by 2 to the next power. So 2 to the 1 times that number, and then 2 to the 2 times that number. And you add all those 2 things together, and that's how you get the decimal equivalent of a number. Let's take a look at an example. It'll make more sense this way. Now, we're not actually converting anything here, but just so you can see how it works, we could do the same thing for a decimal number if we wanted to. If we had the number 4,524, we could convert this to a decimal number the same way. So we'll take this first digit and multiply it by 10 to the power of 0, which is 1. So 4 times 1 is just 4. Then we'll take the next number and multiply it times 10 to the power of 1. So 2 times 10 is 20. We'll move over to the next digit. 5 times 100 is 500. Move over to the next digit. 4 times 1,000 is 4,000. Add them all up, and there is your decimal value. We could do the same thing with binary. So here's a binary number, 1101, and we'll do the same thing. So remember, binary is base 2. So we'll start by taking this and multiplying it by 2 to the power of 0. So 1 times 1 is just 1. Then the next digit, we'll multiply that by 2 raised to the next power. So 0 plus 1, 2 to the 1 is 2, 2 times 0 is just 0. And we'll keep going over, 1 times 4, 1 times 8, you add those up, and this number in binary has a decimal value of 13, right? We're going to skip the rest of this. We'll talk about why binary is important in just a moment. But just so you at least are aware that there are different numbering systems, binary is a really important one for computer science, and at least we're familiar with how to convert from binary to decimal. They have more in here, how to go backwards. We're not going to cover that in this class. All right, some prerequisite knowledge. Here's some stuff that we need to know before we can even start using C. I have 10 minutes left. I'm not going to cover this. If you click this, this is a link that tells you how to use JGrasp. It's a YouTube video. And then I have links for Cygwin, Java, and JGrasp, everything in the homework instructions. So you can either install it from the homework instructions, or you can follow the links in the PowerPoint if you want to download and install these to work along with it. For Mac, again, Xcode instead of Cygwin. You don't need Cygwin, you need Xcode, and then you will need to install JGrasp, sometimes Java as well, if it doesn't have Java already. So let's start with some simple definitions, some things that we need to be familiar with. We'll learn more about how these work later, but for now, we still need to be familiar with the terms and what they mean. And I'll try to give some general abstract explanations of what these things are. Functions are really important in C. They are a core concept in C, and it's going to be one of the first things we learn about once we get through this basic stuff. A function is a command or a set of commands, there should be an S after that, that can be executed by typing in some name. So for example, let's take something that's not programming. Let's say I have a command, I want you to take one step, and I really want you to take 3 steps, right? So I could give you that command 3 times, take a step, take a step, take a step. So I have 3 instructions, or I could group those things together and label it. I said, hey, this group of instructions, I'm going to call it walk. So from now on, when I say walk, you take a step, and then you take a step, and then you take a step. That's kind of what a function is. It's a list of instructions, but instead of having to type all those instructions out one by one, every time you want to do them, you can group those instructions together and label that group. And then you just call the label. Hey, go do that set of instructions, go do this set of instructions. So that's kind of what a function is. Libraries are collections of functions. So it's another level of grouping, right? You have this very low level of grouping where I can take 1 or more instructions and label it, and then call that and execute those instructions. And then you have a higher label where I can take a collection of those. So maybe I have 1 set of instructions for walk, and I have another set of instructions for run, right? Maybe I say take a bigger step, and I have that a couple of times. And I could put both of those in one location, and I'll have that store them in something called a library. And what I can do with the library, I can give it to you now. And I say, hey, if you want to use my instructions, here's my library. And now you don't have to write those instructions. You just can use the ones I wrote. I already made these. You can just use the ones that I made. And now you can say walk and you can say run, and it'll work for you too, because you have my copy of it. So that's what a library is, when you take a bunch of functions, group them in one place, and you save them in, let's say, one file. That's not exactly true, but let's say one file. We'll call that a library. Compiling, we've already touched on that when we talked about Vocarium, right? When we're creating a computer program, we're really just writing in a text file. So the files that we will create, they'll have a file extension. Who in here does not know what a file extension is? A couple of people. Okay, so a file extension. So we've all opened, let's say, Word documents, right? And usually it's some name dot docx. So that docx, that's a file extension. Maybe if you open a text file, it's some name dot txt. That txt, that's a file extension. It's a couple of letters after the period. So a C file, it's going to be something dot C. All that C does is it tells the computer how it should interpret that file. Hey, this is a C program. When you open this, if you have any programs available that work with this kind of file, you should launch that program. That's all that does, but it's just a text file. That's all it is. And compilation is taking that text file where you have things written in it that look kind of like English and converting it into instructions that the machine can understand. So we'll take our first trip down memory lane here. Remember, we talked about binary. Well, it turns out machine instructions are written in binary. They're not written in words. They're written in groups of 1s and 0s, and the machine chooses to interpret them a certain way. So it'll take this text file that's written in words, and it'll convert it to numbers, 1s and 0s, that the machine can understand and the computer can execute for us. So that's what compilation is, taking that text file, converting it into machine instructions. I've simplified it a little bit. There's a little more to it than that, but that's enough for now to understand that. Here's an example of what a very basic C program might look like. At the top in yellow, you have something called an include directive. So these everything that's preceded by a pound sign, these are called preprocessor directives, and they do different things. We talked about compilation, right? We talked about this, taking that text and converting it into machine instructions. Well, sometimes before we can do that, we want to do a couple of extra things. That's what these are for. So pre-processing, before you convert this to machine instructions, do this stuff. So this include directive, this is how we could include someone else's instructions. So recall we talked about libraries. And what if I made a couple of functions I wanted you to be able to use? I could give you my library, my collection of functions, and then you could use them. You don't have to make them anymore. I already made them, you just use mine. So that's what this is. Someone made a library called standard input output, standard io.h, and it has functions inside that allow you to read or print things from the screen. Instead of writing those myself, I could just include that library and it'll import those into my program. So now I don't have to make them. The compiler will include those when it makes my code. You could create variables. So that's what this is an example of. I'm making a variable called X. I'm just going to give it a value of 1. This is not typically the way we want to do that, but there are use cases for doing this. Sometimes we want to write comments. Comments are ignored by the compiler. So if they're ignored, why do we need them? Well, they're for us. We don't read machine instructions. We read English. So sometimes when you're writing your code, it's useful to include comments that explain what the code is doing. We're going to do a lot of simple assignments in here, but in the real world, a realistic computer program may have anywhere from 100,000 lines of code up to 10 million lines of code. So I want to say like the Mac or Windows operating system, it's like 10 million lines of code. When you have that much text to look at, comments are really helpful. Sometimes you forget what things do, or maybe someone else wrote it. I didn't even write it. So if I have to maintain this, I have to work on this, how do I know what it does? Well, that's what comments are for. Comments are for us. So it's always useful to include comments in your code. Typically, if you're going to write a function, right above the function, you want to write some kind of comments that explain what that function does. Here's what it does. Here's how it behaves. Here's what you have to give me. Here's what I get back when I'm done. Then here we have a very special function. So main is an example of a function. It's a very special one. In C, every C program must have a main function. It must have a function called main. Remember, this is the label, right? So this is the label for my set of instructions. You have to have one, and you can only have one. You cannot have more than one. What's so special about this function? Well, when you start your program, your computer has to know what's the first instruction you want me to execute. Here's a program. You have hundreds of instructions in here. I don't know where to start. It always starts here. It's always going to look for this. So you can only have one, but you have to have one. And we'll just, the only instruction I have in here is a print instruction. Again, similar to what I just did in Vocarium, I'm just going to print the word hello. Variables and data types. So what is a variable? A variable is not that different than a variable in math. So if you think about a variable in math, you can write x plus y. We understand that x and y may have values. I don't know what they are right now. You can substitute values for that. That's kind of what a variable is. A variable is some name that you can use to store some value. When I say it's different than math, they're not always numeric values, right? Variables also have something called a data type. And the data type tells the computer what type of information you can store in a variable. So maybe I have a data type that represents a numeric data type, and I would know, okay, X is a numeric data type. You can only put numbers in here. Maybe I have something that's a string data type. Oh, you can put words in here, right? So it represents what kind of things you can store in that variable. Here are some examples of different types. So you have, here is the data type. Here's the official name in C. So if you're writing a C program, this is what you would use in the program. You have floats and doubles. And this type of data is used to store floating point representations of numbers. So you can store numbers, but not whole numbers, decimal numbers, 4.2, 30.6, 4.2367 as this example here. The only difference in the two is that doubles are bigger. So we talked about binary, right? So we'll take our second trip down memory lane. Why is binary important? Well, data types are specific sizes. How big are they? Well, that's a great question. Well, it turns out they are a certain number of bytes. A byte is 8 bits. 8 bits are 8 digits of a decimal number. So 1 byte is 8 ones or zeros. So you can do the math and calculate what's the biggest number you can represent with that. And that's the biggest decimal number you can represent with 1 byte worth of storage. Floats are typically 32 bytes, 32 bits. Doubles are typically 64 bits. So doubles are twice as big, which means you can represent a larger value with a double than you can with a float. Right? You have more space. You have more ones and zeros that you can use to represent values. Whole numbers, you have 3 different types of whole numbers. I have an asterisk here, double, int, character. These are the ones that we're primarily going to use in this class. Right? So int, short, long, these are all different versions of whole numbers. And the only difference, again, is how big they are, how many binary numbers you can use to represent a value. So with a short, you can only use 2 bytes. So you can use 16 ones and zeros to represent a whole number that is a short. With an int, you can use, it's typically 2 to 4 bytes, and a long is the biggest one, 4 bytes. So 4 times 8, that's usually the size of this data type. Characters are used to store a single character. So the letter T, a space is a character. The return key that has a representation, that's a character. The number 1, the number 2, these are all examples of characters. A collection of characters, if you look on the right here, I have an entire sentence. This collection of characters is called a string. When you go through chapter 1, they'll talk a little bit about strings. You'll see that they are stored differently than regular variables. The Boolean data type itself just represents true or false. So you really only need 1 bit. Of course, most computers are not bit addressable. We'll talk a little bit about memory and addressing and how that works later. But you only need 1 bit to represent a Boolean value. It's either true or false, so it's either 1 or 0. As such, C doesn't actually have a Boolean data type, so they don't actually have a data type for this. You can include a library if you want to use something that's kind of like a data type for Boolean. But in general, in C, anything except for the number 0 is considered true, period. The number 0 is false, everything else is true. That's how it handles Booleans. With that, we are out of time, so we'll have to pick up the rest at our next class, which I believe is Wednesday, right? Let me see. I think Monday's a holiday. Yes, Monday's a holiday, so I'll see you all on Wednesday.